2.2c, basic differentiation rules and rates of change. So we're going to continue on with the derivative, but in this section, and I believe the next, we're going to touch on particle motion or velocity and acceleration. So here are a few, I guess, definitions or what things stand for. Position is simply where an object is. Displacement is the change in position. So we will normally see position written as one of two things. S of t, so instead of f of x, it'll be s of t for position, or x of t, which is really weird, right? Because the x is usually what's inside the parentheses, but since for particle motion, we always use time for t. So x is actually not normally the variable, so they use x of t. Okay, average velocity is basically displacement divided by travel time. So average velocity is basically looking for a rate, right? A distance divided by time. It's the way we would find slope in Algebra 1, or known as in this class, the slope of the secant line. Velocity tells you how fast an object is moving and in the direction of the motion. In this class, you can find average velocity, which is the slope that we just talked about, or instantaneous velocity. And instantaneous velocity is actually going to be the derivative. Okay? Now, a way to remember this that I've always used in my brain, average velocity is you're using 2 points, okay? Such as when you did slope back in Algebra 1. Instantaneous, it's at an instant. So since it's at an instant, you only have 1 point. So whenever you only have 1 point, you're looking for the derivative. So you're using calculus. All right, speed is just the velocity, but the absolute value of it. And then acceleration is the rate of change of velocity. So, okay, again, so this, oops, I didn't mean to do that. So this is the rate of change. Acceleration is the rate of change of the rate of change. So basically, velocity is going to be our first derivative. I'll write it down here. Velocity is going to be the first derivative of position. So it is v of t. Acceleration is the rate of change of the rate of change. So acceleration is going to be the second derivative of the position, but it is the first derivative of velocity, and this is how we write it, a of t. Okay, so essentially, all three of these things, they're the same. These are all the same, and these two are the same. And again, these are just two ways that they will show you position. Okay, if you notice in this, let me get the highlighter. This right here is basically acceleration is the derivative of velocity with respect to time. It is the second derivative of position with respect to time. Okay. Example 1. Suppose an object has the position given by the function s of t equals t squared minus 6t plus 4. So for A, we're going to find the displacement. Displacement is just hold on. Okay, so displacement is just s of t minus another s of t and a little 2 and a little 1 subscript. Okay, the first 4 seconds means from 0 to 4 seconds. So those are my x's. So for displacement, basically, I'm going to take my position function, plug in the 4, and then I'm going to subtract whatever I get when I plug in the 0. When I plug in the 4, I get 4 squared minus 6t plus 4. So I'll write it out. 16 minus 24 plus 4. And then minus, when I plug in 0, I get 0 minus 0 plus 4. And then so I have negative 4 minus 4, so negative 8. I don't have units. I'm just going to call it units because I don't have feet or meters or anything. B, find the average velocity. Okay, so average velocity is, you got to think back of average. That means I have more than one number, right? Add them together, divide. It's like slope from algebra 1. So again, it's the first 4 seconds. So I still need my x's to be 0 and 4. But this time, I'm going to use, so s of t2 minus s of t1 over t2 minus t1. So this is good old-fashioned slope, right? So basically, s of 4 minus s of 0 over 4 minus 0. The top, we already know what it is, right? This right here, because this is displacement. It's this right here. So it was negative 8 units. I don't have any units here. I didn't write down any units. So the top is negative 8. And then 4 minus 0 is 4 seconds. So negative 8 divided by 4 is negative 2 units per second. All right, C. Find the instantaneous velocity when t equals 4. So instantaneous, right? It's at one instant, 1 point. Average, I have two things, and I'm finding their average. Okay? Whatever works to help you remember which one is which. So instantaneous velocity, I'm actually going to take the position function, which I have lost it from my screen, but here it is. T squared minus 6t plus 4. I'm going to take the position function, and I'm going to derive it. So s prime of t, well actually, don't write that. I want the velocity function, which is the first derivative. There you go, that looks better. So velocity is the first derivative of position. So I'm going to derive. So 2t minus 6. And so now that I have my derivative, velocity at 4 seconds is 2 times 4 minus 6. And that's 8 minus 6, which is 2. And that's my velocity. Again, I don't know units, but I'll write them down anyway. Units per second. Okay. D. Find the acceleration of the object when t equals 4. So acceleration is the derivative of the derivative. So it's the second derivative. So if I want to find acceleration, it is the first derivative of velocity, which is the second derivative of position. So let's see. Here's my position function. I can just go ahead and derive that. And we did, right? Which is down here. And now then I would have to derive it again. Right? There's no point in doing all the work again if this is the same problem. So the derivative of 2t minus 6 is 2. Now, acceleration, it's still units, but it's units per second squared. I'll show you that later. I have a better example where to show you that. But just take my word for it for right now. All right. Initially, whenever you see that in a problem, you need to be thinking at the beginning. So when t equals 0, right? And t is time, of course. At the origin means that you were located at the beginning. So that means your position was 0. So I'll write position And we could do s of t equals 0. At rest, if you're resting, it means that velocity is 0. Um, Whenever you see the word when, that does refer to time, so you're trying to figure out what the time is. What is t? If the velocity of the particle is positive, so if we have a problem dealing with particle motion and the velocity particle, the velocity of the particle is positive, then the particle, we say that it is moving to the right. Or sometimes the right is considered forward. You can write that if you like to. Forward. It depends on the problem. If the velocity of the particle is negative, then the particle is moving or said to be moving to the left, which is sometimes backwards. It depends on the problem. If they're talking about forward and backwards, it's the same as right or left. In order for a particle to change direction, the velocity must change signs. So, like velocity, if it was suddenly positive velocity, and then negative velocity, so basically increasing and then decreasing, then the, I'm forgetting words, particle change sign. So plus and minus. Let's just leave that there. Okay, an object has 0 velocity when it reaches its highest position. Okay, so you need all of these to answer some problems. All right, so example 2. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. The position of the diver is given by, so we have f sub t equals negative 16t squared plus 16t plus 32, where s is measured in feet and t is measured in seconds. So for A, says when does the driver, when does the diver hit the water? So what that is asking is, at what time is the position 0? Because this is basically a parabola, but it's upside down. Oh, I can't write. So if you look at the picture, um, basically it's this. Although the dude started from up here, but position will be 0 here and here. So when does the diver hit the water? You're actually looking for the time, right? When? At what time does the position equal 0? So the time that s of t equals 0, which is easy enough because you just take your equation and set it equal to 0 and solve. You're just going to factor. Find your solutions for t. I see negative 16, well, I see 16 in common here, a common greatest common factor. I don't like the negative, so I'm just going to go ahead and factor out the negative as well. So I have t squared minus t plus, or, well, sorry, I'm taking out the minus, so that should leave me with a minus, right? So again, I'm factoring out the negative because I don't want to deal with the negative. So I divide this by negative 16, divide this by negative 16, and divide this by negative 16. Okay? Alright, so the negative 16 is there, but it's okay because it has no effect on my factors. So I need two numbers that multiply up to negative 2, but add up to negative 1. So the numbers 1 and 2 come to mind. They certainly multiply up to 2. But if for them to subtract to negative 1, or sorry, add to negative 1, if this is the negative and this is the positive, I get negative 2 when I multiply, and I get negative 1 when I add. So then that means that t is equal to negative 1, or t is equal to 2. So I have my two answers. However, one of them is no good. Because if you recall, that is when the diver jumped. So therefore, this, nope, that's not within my domain, basically. It's not within my time interval. So this is my only answer. And there is my answer written out completely correctly, please. You actually have to be able to answer these questions in such a way that explains what your answer means. Okay, t equals 2 does me no good. I need you to be able to say the diver hit the water at t equals 2 seconds, or at even just 2 seconds. Okay, B, what is the diver's velocity and impact? Okay, so what you're actually doing here is you're finding the velocity at the instant that the diver hit the water. Well, when did the diver hit the water? Oh, right here. It hit the water at t equals 2. So what you're doing is you're finding the velocity at t equals 2. So your job here is to find the velocity when t is 2. So that's what we're doing for B. So in order to do that, I need velocity, don't I? Currently, I just have the position function. So that means I'm going to have to derive it. Let's see. I'm going to use this right here. You have it on your paper, whatever. So if I derive that, I get negative 32t plus 16. And that is my velocity. So then what I want to do is I want to plug in the 2. So negative 32 times 2 plus 16. And then so negative 64 plus 16. And then I get negative 48. And this was seconds, and I don't remember feet. Okay. So, oh, feet per second, Narita. So feet per second. So it is negative 48. Why is it negative? Because he's coming back down, right? So can't talk. The diver's velocity at impact is negative 48 feet per second. And there's your answer written out. Okay. C. Oh, there is no C. Next. Okay, example 3. A dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. It reaches a height of s equals 160t minus 16t squared feet after t seconds. A. How high does the rock go? Okay, so what that means is what is the position at the time that the velocity is 0? Because objects reach their maximum height when velocity is 0. So this is basically what I said. Objects reach their maximum height when velocity is 0. So we are looking for here, what is the position when the velocity equals 0? The when part, of course, means the time. So what we're going to do is we're going to take velocity, the velocity function that we will find after we derive, and we're going to set it equal to 0. So I'm going to go ahead and just derive this. So velocity is 160 minus 32t. I'm going to take this and I'm going to set it equal to 0. So 160 minus 32t equals 0. I don't like the fact that the t has the negative, so I'll just move that way. So 160 equals 32t. And so now we'll just use algebra. So divide both sides by 32 and 5. Yeah, 150 plus. Okay, so t equals 5. This is seconds, but I have my t. So now that I have the time at which the velocity is 0, my job is to find the position. So then I'm going to take the position function, and I'm going to plug in my t equals 5. So 160 times 5 minus 16 times 5 squared. So 500 plus 300 is 800 minus 25 times 16. What's that? 400. Okay. So we have 400 and I already forgot. Okay, feet. So 400 feet. So let me write out the answer in a sentence. And there you go. The rock's maximum height is 400 feet. I have to be able to explain what it is I just found. 400. That means nothing. But now in the context of this question, by me writing the rock's maximum height is 400 feet, then that means something. All right, B, what is the velocity and speed of the rock when it is 256 feet above the ground on the way up? And then it asks for on the way down. Okay, so remember, the function is a parabola. It's an upside down parabola, so it looks like a U upside down. Okay, and obviously whatever goes up must come down, right? Laws of physics. So the rock is going to go up, and then it's going to come back down. And so they're just asking for the velocity and speed on its way up when it reaches 256 feet, and then the velocity and speed on its way down when it reaches 256 feet. So what we're doing here is we need to know the time, okay? Because, see, the velocity function, all I need to plug in is the time and I can get the velocity. Speed is the absolute value of velocity, so I really don't have to do extra work there. All right, so I wrote down my position function. And again, I'm trying to figure out, or I need to know the time. At what time is my position 256 feet? Now, obviously, this is a parabola, so there should be two positions at which I am located, or sorry, two times where my position is located at 256 feet, right? Once up, and once on the way up, and once on the way down. So I'm going to take this function, and I'm going to set it equal to 256 feet. So 160t minus 16t squared equals 256. And so then, again, the negative, I don't like it, so I'm just going to move these that way. And I'm going to end up with positive 16t squared minus 160t plus 256, and they're going to equal 0. Okay, so here's my equation. I can factor this. These numbers are a little, well, the 256 is a little big, but 16 does go into all three of these, so that is my common factor. So 16, so I have t squared, and then I have minus 10t, and then 256, 16 goes into 256 16 times, right? So positive 16. And then so I can factor. So I need two numbers that multiply up to 16, but add up to negative 8. I mean, negative 10. So I have 8 and 2. If they're both negative, I get a positive 16, and they will add up to negative 10. So they're, okay, so t is 8, and t is 2. So this is when the times where my position is 256. Once is on the way up. Obviously the, oops, I can't write. The t equals 2 is on the way up. Way up. And the t equals 8 is coming back down. On the way down. Okay, so velocity. All I gotta do is take my velocity function that I did find in A, right, part A, which was 160 minus 32t. And all I have to do is plug in the times. So v of 2 and v of 8. All right, so I have my 96 feet per second for v of 2, and for v of 8 I have negative 96 feet per second. I didn't think you'd really needed me to do that for you. So my velocity going up is 96 feet per second. My velocity going down is negative 96 feet per second, right? Because I'm going down. Now the speed, however, the speed at both times, the speed is 96 feet per second, because speed is the absolute value of velocity. So even though v of 8 is negative 96, even though that's the velocity, My speed is 96. Okay, so we're now on part C. What is the acceleration of the rock at any time t during its flight after the blast? Okay, so for what part C is, I'm trying to simply, um, I need the equation that will get me acceleration. I need the function, okay? That's why it says at any time, because it doesn't matter the time. I'm not asking you for a specific time. So what you do is you just find the function, the acceleration function, and then whatever time is chosen can be plugged into it. So you're just finding me the function. Okay, now remember, acceleration is the second derivative. So position, if I derive it twice, or if I just have velocity, and I can just derive that once. Okay. Now we do have velocity, so I don't have to start from the beginning. Okay. So 160 minus 32t. Acceleration, which is the derivative of that. So if I derive this, I just get negative 32. So it's not even a function. It's already a number. So my answer is the rock has an acceleration of negative 32 feet per second squared. All right, D. When does the rock hit the ground? How long was the rock aloft? Okay, these questions are technically the same. But what it's saying is, for the rock to have hit the ground, my position has to be 0. Kind of like example 2, part A. So we're going to find the time that, like when, sorry, my position is actually 0. So we need the position function again. So S of t equals 160t minus 16t squared. And so I'm going to set this equal to 0. And then I'm going to solve for t, right? You can factor this. There's a greatest common factor of 16 and t, right? But again, remember the negatives. They're kind of in my way. So I'm going to just trade this up. I'm going to move these that way and the 0 to the left. So basically 0 equals, or actually maybe this looks better, 0 equals positive 16t squared minus 160t. Okay, so there's a greatest common factor, 16t, so that leaves me with just 1t there, and then this is just 10. So I have 16t equals 0, which means t is just 0, or I have t equals positive 10. So there are my times. So now I'm simply left with the task of answering, when does a rock hit the ground? Well, the rock hits the ground after 10 seconds. So I wrote that out. How long was the rock aloft? Well, if you think about it, the rock is up in the air. Oh, I'm sorry, if you didn't know what aloft means, that just means up in the air. So up in the air. So to answer that question, well, if the rock hit the ground after 10 seconds, then how long was it up in the air? 10 seconds. So it is the same answer, just looking at it two different ways. So let me write that. And there's the answer. The rock is aloft for 10 seconds. And that is it, folks. There aren't any practice problems. So see you in class.